Chemical reactions are the essence of our world, transforming everything from the stunning hues of a sunset to the vital processes in our bodies. At their heart lies the breaking and forming of atomic bonds, giving rise to new substances with unique properties. This intricate interplay explains the rich diversity of materials in nature. So what makes a chemical reaction happen? Come on, let's get into it.
First up is activation energy. This is the minimum energy required for a reaction to take place. It acts as a barrier that reactants must overcome to transform into products. For example, lighting a match involves striking it to create friction, providing the activation energy needed to ignite the chemicals on the head. Without the spark, the match won't light. Next, let's discuss proper orientation. For a reaction to occur, reactant molecules must collide in the right way. They need to align correctly to break and form bonds effectively. In the reaction between hydrogen and oxygen to form water, the molecules must collide in the correct alignment for water to form. Now, let's look at the factors that affect chemical reaction. First is concentration. Higher concentrations of reactants lead to more collisions and increase the likelihood of a reaction. Next is temperature. Higher temperatures provide molecules with more kinetic energy, which increases their movement and collision frequency. Another important factor is surface area. A larger surface area allows for more collisions to occur. Have you heard of catalysts? They're like helpers to speed up reactions without being used up.
But how do we know that a chemical reaction has occurred? Some evidence are 1. Change in color, 2. Evolution of gas, 3. Change in temperature, and 4. Formation of solid or of precipitate. Today, we will obtain a precipitate from the chemical reaction between sodium hydroxide and copper-2 sulfate. When copper-2 sulfate reacts with sodium hydroxide, it forms a blue precipitate of copper-2 hydroxide and sodium sulfate. Come on, let's do the experiment.
First, I'll add distilled water to 2 beakers. In one, I'll dissolve sodium hydroxide using a stirring rod. In the other, I'll add copper-2 sulfate and stir until it dissolves. Then, I'll pour the sodium hydroxide solution into the copper-2 sulfate beaker. This causes a blue precipitate of copper-2 hydroxide to form along with dissolved sodium sulfate.
Chemical reactions help us understand how substances behave. By observing how one substance interacts with another, we can learn its properties and identify unknown materials.
Without chemical reactions, everything would stay the same. Atoms wouldn't change, new molecules wouldn't form, and life wouldn't exist.